Hey y'all, welcome back to Miss Meekin's Mansion. We have another notes video that we're going to go through. So here it goes. First, I want to remind you, make sure that you have pencil and paper, something to write with, take notes down, adding any tips that you didn't know or need to remember for your knowledge. Okay? So today's lesson of the day is factoring trinomials, aka polynomials. And as you all can see, Ms. Meekins made a grammar mistake, so I'm going to fix that. Alright, cool. So we have just some vocabulary words. I always like to key you in the vocabulary. You have to know what the word it means in order to be able to attempt the problem. So the word factor, again, means to break apart. So to determine the two terms or numbers that multiply together to get the original term. Then we have trinomial, that prefix tri, meaning three. So it's a polynomial expression with three terms. We have binomial, prefix bi, meaning there are two terms. And then we have our polynomial, which is our overarching expression that's made up of more than one term. We mostly see this as a quadratic expression because we have this ax squared quadratic expression in the beginning of the expression plus bx plus c. So that's the type of expressions we'll mostly see in this lesson when it comes to factoring. Alright, so there are three methods for factoring. There could be more. There could be 18. I try to focus on at least three just to minimize the strategies in your toolbox for you to use. We have greatest common factor, aka GCF, product sum method when our a value equals 1, and slide and divide method when our a value is greater than 1. That's, of course, talking about trinomials using that expression ax squared plus bx plus c. All right, so in this line, I'm going to talk about greatest common factor real quick. So greatest common factor is the greatest value or terms an expression have in common. So they can have a 2 in common, they can have an x in common, they can have a 2 and an x in common. So whatever the greatest is in common, these terms are factored out of the expression. Okay. The GCF is placed on the outside of the parentheses, so it goes in this part here, outside of your parentheses, and the remaining factors go on the inside of the parentheses. Be cautious of your sign changes, so positives, negatives, plus signs, minus signs, watching out for those. So here's an example real quick on greatest common factor. So we look at all three of our terms, 4x squared minus 4x minus 8, and we ask ourselves, is there any term that they have in common, number or variable? Well, I know my even numbers automatically all have 2 in common, and I see that 4 and 8, when being multiplied together, we have 1 times 4 and 2 times 2. When being multiplied together, we have 1 times 8 and 2 times 4. Well, what is the greatest number that they have in common? They have 1 in common, they have 2 in common, they have 4 in common, but 4 is the greatest number, so we're going to choose those two factors. Now, because 4 is the greatest common factor, we're going to pull that number out of our trinomial or our polynomial, and what's remaining is the opposite factor in any leftover terms that we did not touch. So if I took out 4 from my 4 times 1 to equal 4, that means that 1 is left over in x squared. And maybe I should make that a different color. Let's do blue. I got it. Hold on. Cool, 1x squared. That's a really big square. Sorry, y'all. All right, then the minus 4x, well, that same is the 4, but we did not do anything with negative 4. We look at this as positive 4, so I'm going to keep that as minus, and then I'm going to make that a 1x. And then the same with our 8, it's minus 8, so we're going to keep our minus sign, but because we factored the 4 out, we're going to be left with 2. Okay, and that is our factored expression factoring out the greatest common factor. So this would be my final answer. Okay, if they ask just for greatest common factor. From here, we can then move on to our other method, which would be using the product and sum method. All right, so here are your quick notes about factoring with product sum method. Given a polynomial or specifically a quadratic expression, because sometimes we might not have a B term or we might not have a C term. We are factoring. Our factoring results in two binomials, okay? So we might have that greatest common factor on the outside like in the previous slide, but then we could have two binomials on the outside as well. So in order to factor using the product sum method, we need to know which is the product and which is the sum. So our B term is our sums, what two factors add together to get the B term. Our C term is our product, what two factors multiply to get C. So I'm going to show an example on the next page. Again, some of us are familiar with this. If we're not, pause it, replay it, do the example again until you can get the answer with the example, and then move on from there, okay? All right, so they want us to factor x squared plus 8x minus 20. We need to first identify if we're using our product sum method. Well, yes, we know we're using our product sum method because our a value is 1. So we can go ahead and use our product sum chart, identifying that our b value, which is our sum, is going to be our middle term ax. Most importantly, the 8, and then our C term, which is going to be our minus 20. Okay, make sure that we keep that sign with it, and that is the term we're going to be using for our product. So let's create our table, and I might have to go to the different slides, so just keep your notes. So product sum chart, right? We're writing the number that we want to get that multiplies together to get negative 20, and then when I add those two numbers together, I end up getting a positive 8. So this is where you use the trick in your calculator. All right, so use your calculator trick to find your possible factors. I'm only going to list a few here just because I have limited space. So I know if I were to do 1 times negative 20, I'm not going to get to 8 when I add these, so I'm not even going to worry about that one. But I know maybe if I do 4 times negative 5, and I want that to look like a multiplication. Okay, the opposite of that is negative 4 times 5. We also have 2 times negative 10, and then the inverse of that is negative 2 times 10. So then if I add these numbers up, 4 plus negative 5 is negative 1. Negative 4 plus 5 is positive 1. 2 and negative 10 is negative 8. Negative 2 and 10 is positive 8. So again, here, I know I missed showing you what I'm doing here, but I'm adding these two numbers. Okay, I'm going to just show that out just because everyone does not remember. Okay? All right. So adding those two numbers, once we get our product and our sum, so our handy dandy what two numbers multiply to get negative 20, and then when I add them, get me positive 8. Those are going to be the factors negative 2 and 10. So we're going to take those factors. Remember, our final answer when we're factoring a trinomial, more importantly, a quadratic expression, they end up in binomials. So we start off with the variable that leads our trinomial, which is x in this part. And then our factors are negative 2 and positive 10. So we keep the signs that go with them. So I'm going to put those in red. So this is going to be minus 2 and positive 10. Also, remember that your inverse rules apply as well. You could have had 10 and negative 2. So plus 10 could have gone first and then negative 2. All of those are okay as long as you can identify the complete and correct factors. So once you have your factors, you can always go back and check your answer to make sure you get the original. Okay? All right, so here are your quick steps real quick using the slide and divide method. This is an add-on to product and sum. So if our a value is greater than 1, that leading coefficient is greater than 1 after GCF. So let's say we did greatest common factor. We found out that these numbers all have something in common. We pulled it out. We still have an a value that's greater than 1. We are going to use the slide and divide method in order to factor that expression. So quick steps are not perfect. They're just going to guide us through. Multiply the a term by the c term and then rewrite our expression. Because our a value would now be 1 once we rewrite that expression, factor using the product sum method. A result will be 2 temporary binomials. 3, divide the temporary factors by the original a value, and you'll see what that looks like if we can't remember. and reduce the fractions if necessary, and determine the final factor. So if not easily divisible, slide the remaining value, the denominator, to the front of the binomial. All right, so I'm going to do my best to show this problem. It will probably take multiple slides. So again, pause as many times as you need, rewind, and go back. So we're going to factor the expression 9x squared plus 6x minus 8. Okay. I see that 9, 6, and 8, they all aren't even numbers, so I know they don't have 2 in common. These have 3 in common, but all 3 do not have this number in common, so there is no greatest common factor. But we do have an a value that is greater than 1, so this is going to prompt us to use the slide and divide method, which tells us to first multiply the a term by the c term. So our a term is our 9, and our c term is our -8. So I'm going to rewrite the problem first. So I'm going to multiply those two numbers. I kind of just show that by doing the slide part of slide and divide, multiplying 9 times -8, and then rewriting that expression so that now turns into x squared plus 6x minus 72. Okay, now because our leading coefficient is a 1, we can use our product sum method in order to factor or break this up even more. So from here, we find our two values that we need in our product sum chart, our B value and our C value. Maybe not use the same colors. Our B value and our C value from the beginning of the video. So -72 is our sum. So we want to know what two numbers multiply to get that, and what two numbers add to get 6. I suggest you pause the video now and find out those numbers on your own. I am going to find out those factors and put the possible answers at the bottom. All right, so as you can see, I finished up our product sum chart and identifying that the two numbers that multiply to get -72 and 6 are here, -6 and 12. So we're going to write those as our temporary factors. So our binomials go in parentheses. The variable that we're using is x minus 6 and plus 12. All right, so now that we have our temporary factors, we only did product sum method. If we were to multiply these two factors that we have here to check our answer, we would go back to getting this answer, but we actually want to get to our original answer. So we have to undo that slide in the beginning of our problem, which was multiplying a and c and dividing now by that a. So we're going to take the temporary factors, which are 12 and -6, and we're going to divide them by the original a value, which was 9. Okay. So when I divide these, I'm still left with my x. Handy dandy x kind of never leaves us, right? But then I'm going to reduce these fractions, and I have my calculator here, so I'm figuring out what is -6 divided by 9. And I come up with, we have -2/3. And we have +4/3. So as you can see, I reduced these fractions. Okay, but this is not our simplest form. Okay, we want binomials. We want easy, clean binomials. So this is when the last part of slide and divide comes in. Any of those hanging over terms, remainders, aka the denominator, are hanging from your factors, we're going to slide them into the front of the binomial. So let me find a different color. We're going to slide this 3 in the front of our x term. So our final answer, I'm going to leave it in bright blue. Here is going to be 3x minus 2. And this is when it's going to be 3x plus 4. Okay. So quick things to stamp here. Again, remember that your a value needs to be greater than 1 after GCF, okay? And that you are multiplying and then using product sum and then making sure that you are coming back and dividing that a value out. And always, always, always going back and checking your final answer, making sure that you get the original that you started with. All right, so that was just a short video of those 3 ways of factoring: greatest common factor, using the product sum method to factor, and then adding on the slide and divide method in order to factor. If you have any questions, take these 3 tips below. Hope you all do great on your independent practice assignment and your exit ticket. Again, do not hesitate to ask for help. Bye.